let us start looking at mass, volume, weight, and density. Mass, volume, we have mass, volume, weight, and density. So the reason as to why we are talking about the four aspects, that is how they are related from one way or the other. When we talk about mass, volume, weight, and density, that is how they are related. So if you start by talking about mass, this is the quantity of matter in a substance. That is referring to us as the mass. Then volume is the amount of space that is occupied by matter in an object. When you talk about weight, what do we call weight? Force that has been exerted by gravitational pull. So it is from the gravity. Then density is the mass per unit volume. So before we talk about that, we need to know the units of mass. Units of mass. There is a formula that is being used when we are talking about the units of mass. So the formula is applicable when we are talking about mass, when we are talking about length, and when we are talking about capacity. So for the mass, we have what Kenya has dug. We are in mass. Great developments, great dams now, containing magic. That is a formula. Whereby Kenya means kilogram, has means hectograms, dag means deca, then great means gram, then dams mean decigram, then we C means centigram, and M means milligram. So Kenya has dug great dams containing magic. Kofia huuzwa dukani ga Daudi senti. For those who like Kiswahili. Kofia huuzwa dukani ga Daudi senti. Then from one unit of mass to another, there is a difference of 10. From one unit to another, there is a difference of 10. And then the units are increasing from milligram to kilogram. Then from kilogram, we are supposed to move to tons. And we know very well that 1,000 kilograms is equal to 1 ton. So this formula, for example, we want to know the relationship between grams and milligrams. So you simply underline milligrams and grams. Then you count how many tens have been locked inside. We shall have 1, 2, 3. So because we have 10 3 times, we multiply 10 times 10 times 10, we shall get 1,000. That 1,000 is given to the smallest value to be equal to 1 gram. If you want to compare grams and hectogram, you come to gram, draw a line, then you also draw a line in front of hecto. After that, you find how many tens are in between the two lines. How many tens are between the two lines? We have 10 and 10. So 10 times 10 will give us 100. That 100 is given to the grams, because when we are comparing hectogram and grams, grams become a smaller unit than hectogram. So it means 100 grams will be equivalent to 1 hectogram. If you compare grams and kilogram, a line on grams and a line on kilogram, in between the two lines, we shall have 10, 10, 10. That means 10 3 times. So 10 times 10 times 10 will give us 1,000. That 1,000 is given to the grams. to be equivalent to 1
kilogram.
Then finally, under NB, 1 ton is equal to 1,000 kilograms. That is what is outside the formula. The rest can be gotten by writing Kenya has dug great dams containing magic. So this will help us simplify. If we are told to convert centigrams to grams, you simply come to centigram, you draw a line, come to grams, you draw. You identify how many tens are locked in between the two lines that you've drawn. You will realize that we shall have 10 and 10. So 10 times 10 will give us 100. That 100 is given to centigram to be equivalent to 1. Is that clear, Fabio? Yeah. So that is under units of measurement. So importantly, let us look at mass and weight. So that is the main business for today. Mass and weight. Just as I've said earlier, mass is the quantity of matter in a substance. The matter that is in you is your mass. That is why when you step on that particular measuring, the device for measuring the mass, you are able to read the mass that you have in terms of kilograms. Then weight is resulting as a result of gravitational pull. The force of gravity acting on you, that is making you to be stable on the Earth's surface. That is your weight. So there's a slight difference between weight and mass. Mass, the quantity of matter in a substance or in you. Weight is the gravitational pull on a substance. So when we talk of weight, the weight of an object is the force on the object due to gravitational pull. So let us start by defining mass. This is the quantity. Remember, there's quantity and quality. So this is the quantity of matter in a substance. While weight this is the force on the object or on an object due to gravitational force. That is what we refer to as weight. It is the force on the object due to gravitational force. So the gravitational force is on the Earth. The gravitational force of the Earth. Remember, when we talk of gravity, this is the force that pulls object towards the center. Suppose we could have not been having gravitational force, we could have been wallowing on air. People would have been flat. So it is this force of gravity that is making us to stabilize at the center of the Earth. Then now weight. Because weight is a force on the object due to gravitational force of the Earth, weight therefore given by, denoted by capital W, is given by mass, which is M times gravity, times gravitational force. So gravity is denoted by G. Meaning we can have weight is equal to mass times gravity. So once we have known this formula, we can make any to be the subject of the formula. If we have weight is equal to mass times gravity, then mass will be equal to weight divided by gravity. That is calling for what we call making one unknown to be the subject of the formula. Meaning, if weight is equal to mass times gravity, then we have weight is equal to mg, because this one also means mass times gravity. If we want to make m the subject, meaning we only need m to remain on this side of the equal sign, then we carry out inverse operation. The inverse operation for this, because this is m times, will be dv. So we shall divide both sides by gravity. This side also by gravity. G will cancel G. We shall remain with mass is equal to weight over gravity. But suppose we wanted to make gravity the subject, then we shall be having weight is equal to mg. To make g to remain on this side, we divide by m. The moment this side is divided by m, this side also will be divided by m. This m cancel that m. Our gravity will remain to be equal to weight all over mass. So any of them can be made to be the subject of that. So back to weight. Let's look at different examples. Before we look at different examples, let us note under NB. Gravitational force on Earth's surface is approximately 9.8 Newton per kilogram. So always they usually give it to be 9.8 or 10. That is the value that is supposed to be known because it refers to as a constant. So the gravitational force on Earth's surface is approximately this. Meaning, any calculation that is going to involve weight is supposed to be using this particular value as the gravitational force. Are we together there? Supposed to be using that as the gravitational force. So it is always 9.8 or 10 Newton per kilo. Then the SI unit, that is note dot 1, dot 2, SI units for weight is Newton. The SI unit for weight is Newton. It is measured in Newton, denoted by capital letter N. Denoted by capital letter N. So let us look at different examples on how to calculate weight of different objects. Then, the gravitational force varies from one heavenly body to another. If you are on Earth, it is 10 or 9.8. If you move to Jupiter, you will realize that the gravity will change. If you move to Mars, the gravity changes. If you go to the moon, the gravity also changes. That is why if they will refer to another heavenly body other than Earth, they will have to provide you with the gravitational force. They will give you the unit for that particular gravity. So examples. Determine the weight of each of the following on the Earth's surface in bracket use gravity to be equal to 9.8 Newton per kilogram. Use gravity to be equal to 9.8 Newton per kilogram. The first one is 4 kilograms. That is the first example. Then example B, we will have 50 kilograms. So let us now look at different examples. So the first thing, we've said that gravitational force is always 9.8 Newton per kilogram. So that one has been taken care of in the formula. We have also been provided with the masses of different objects or different items. The first mass is 4 kilograms. So we can get weight. So the solution, we first write weight is equal to mass times gravity. Is that clear? Weight is equal to mass times gravity. We have been given the mass to be 4 kilograms times. What is the value of gravity? It will be 9.8 Newton per kilogram. Newton per means Newton over. That is what we mean by the term per, meaning Newton per each kilogram or per unit kilogram. This kilogram will cancel that kilogram because of the term per, meaning we were supposed to be having this kilogram over down. So you want to simplify kilogram cancel to. Is that clear? Yes. Then we shall remain with 4 multiplied by 9.8. What will we have as the value of weight? 39.2 Newtons. 39.2 Newtons. So you can easily realize that the SI unit, the international standard unit of measurement for Newton remains for mass, for weight remains to be. Example number 2. The mass is given to be 50, weight is given by mass times gravity. Our mass is now 50 kilograms times 9.8 Newton per kilogram. Kilogram cancel, it's remained with 50 multiplied by 9.8 Newton. What is the value of that weight? 490 Newton. 490 Newton. 490. More examples. I hope you clear with this part. Yes. $50 hectogram. 50 hectogram. 50 hectogram. So when we are given a different unit other than kilogram, we have to convert that unit to kilogram. Why do we convert to kilogram? The gravitational pull that we are going to use is in Newton per kilogram. So if you use hectogram, then it means that the units are not going to tally. So you have to convert this to kilogram. Even if it is given in grams, you must convert it to kilogram. So you go back to our conversion. Kenya has dug 8 dams containing 10, 10, 10, 10, 10. So we are converting hectograms to kilograms. So you come where we have hectogram and kilogram. How many tens are in between them to the look? 1 10. So it means that for us to convert this, we will be using 10 hectogram is equal to 1
kilogram.
From that particular formula. Between hectogram and kilogram, there is a difference of 10. So that 10 is supposed to be given the smallest unit. Then you argue by saying 10 hectogram is equal to 1. Therefore, what about 50 hectogram will be equal to what? It will be 50 hectogram. You cross multiply by 1 kilogram. Then you divide by 10 hectogram. The hectogram cancel. 0 cancel.
0.
So remain with 5
Kilogram.
Then once we have changed hectogram to kilogram, we can now say weight is equal to mass times gravity. Our mass is 5 kilograms multiplied by 9.8 Newton per kilogram. Kilogram will cancel. 9.8 times 5
49.
will be
49 Newton.
49 Newton. Will be 49 Newton. Last example. Two tons. So we first convert tons to kilo. How many kilograms make 1 ton? How many kilograms make 1 ton?
1,000.
So we come and say that if 1 ton is equal to 1,000 kilograms, therefore what about 2 tons? What about 2 tons? So 2 tons will be how much? It will be 2 tons times 1,000 kilograms divided by 1 ton. Ton will cancel. So remain with 2,000 kilograms. Then weight is given by mass times gravity, which will be given to be our mass is 2,000 kilograms times 9.8 Newton per kilogram. So it is just a matter of multiplying mass times the gravitational force. And gravitational force you will be provided with. They will have to give you the gravitational force. If it is on Earth, it is going to be 9.8 or 10. 10 when it is rounded up to the nearest whole number. So kilogram cancels the kilogram. And I explain why kilogram is cancelling this. Because we have got this mass times this one Newton per. Newton per means that they have divided Newton by the number of kgs. So meaning kgs was supposed to be below here. So when we are dividing the upper value by the lower value, if there is a unit that is the same, we cancel each part. So it is like this one was supposed to be 2,000 kilograms times 9.8 Newton over 1 kilogram. So this kilogram will cancel the key. 2,000 times 9.8.
19,600.
19,600 Newton. Any question? Any question? Any question on that?